All right, so one of the things that people are really good at coming out of grade 9 and 10 math is how to answer a word problem, but there's always people that like sort of miss the details. And I think that we all have like a friend that's that messy person that doesn't keep track of their givens or their let statements or whatever. So we're just gonna sort of like quickly hash through what sort of things would be expected in a physics class. So a nice friendly situation where we have a horse that's running at 4 meters per second west, and then they accelerate at 3.5 meters per second squared west. And they do that for 4 seconds. And we want to know what her velocity would be at the end of the 4 seconds. So things that we have as givens. Well, before we do anything, I noticed that there's some mentioning of west here. And so it makes sense to me that I should probably define a reference frame. I'm going to make an assumption that horses, well, this horse at least, doesn't go north or south. And there's no mention of the horse going up or down. So I think that having an east-west reference frame is going to make sense. I'll make east be this way. I'll make west be this way. Looks like our horse is continuously running towards the west. And even though this is a really simple situation, I'm going to draw myself a stick figure diagram just to exemplify that it's okay to have a stick figure diagram. So if you've ever watched or looked at one of these like Neolithic cave paintings or something like that, this is a horse, okay, running. So you don't have to be an artist to do a diagram. Trust me, I can draw a better horse than this. I'm trying to emphasize that it doesn't matter, okay? So we have this horse, and it's going to start off at 4 meters per second, and it's going to accelerate towards the west. So I predict that it's going to be going even faster at the end of 4 seconds. And this is just me trying to think out what's going to happen here with my predictions, my thinking. And I say, okay, well, in terms of my givens, this first V, what would I call it? V1 or V2? V1, it's the initial velocity. V1 is equal to 4.0 meters per second. And it says that it's west, but here I am trying to convert English into math. So I'm going to immediately call it positive, 4.0 meters per second, because I've already declared that to the west is positive, and I know that I want to mathify this thing. I don't want to write a sentence about it. I know that V2, oh shoot, that's what I want to know. That's the unknown thing. What's her velocity at the end of 2 seconds? So I'm going to skip over that. I could write a question mark for myself if I wanted to. What's this 3.5 meters per second squared? What information is that? Acceleration, yeah. So from a variable perspective, there's a little bit of decoding going on here, but not a lot. The acceleration is 3.5 meters per second squared. And again, because it's west, and I've declared west to be positive, I'm probably overdoing it right now, but I want to make it really clear that that's a positive because I acknowledge that it's west, okay? And then in terms of the time, looks like this is going to take 4 seconds to complete, 4.0 seconds. Now, you could do this formally or you could do it informally, but in my mind, I'm already looking at all this stuff and I'm recognizing that there's only 2 significant figures. Okay, so that's something that I have as a mental note for myself for future rounding. Yep.
So we don't have to write the arrow over velocity.
Oh yeah, that's a good point. So it's been noticed that I'm not writing the arrow over top. Now at a certain point, and I'm going to start doing it right now, at a certain point we may find that we're doing so many of these calculations that out of laziness, we don't write an arrow over top of every one of our vectors. Okay? Now, strictly speaking, those guys should all have arrows over top of them because they're all vector values. But you'll notice that as I do my calculations, I'm going to write my units throughout all my calculations, but one of the things that I tend to drop out is the arrow. And a lot of people will drop out that arrow as they go through their calculations just because it's, let's say, cumbersome. If I was going to publish, I guess I'm like going to publish this to YouTube, but if I was going to publish in a textbook or something like that, I would keep the arrows everywhere, okay? But for expediency, we're going to drop the arrows as we do our math. And I'm okay with that. Now, if you find yourself with a professor or something in the future that's not okay with that, you just roll with it, okay? You do whatever's asked of you, but I'm going to drop the arrows when I do my calculations, okay? All right, so with the analysis, a formula that I happen to know for this one is acceleration is equal to delta V over delta T. Remember, inside of delta V, I actually have a V2 minus V1 binomial embedded inside of that. So I'm going to write that out as well, divided by, now I could say T2 minus T1, but notice that I've got the whole delta T value here, so I'm not going to expand that one out. That would be overkill. So delta T. And then I'm trying to get the V2 all by itself. So it seems to me that the best thing that I could probably do is multiply both sides by delta T in order to clear the denominator. You notice what I'm not doing. I am not subbing in my values. I'm isolating the variable first. This is one of our basic algebra skills that we want to make sure that we nail down right away. And hopefully everybody does well on the basic algebra quiz. But we want to get the V2 all by itself. So at this stage, if you really wanted to, you could rewrite things. You could say, okay, well, maybe I'll take that V2 minus V1. I've already cleared the denominator, is equal to acceleration times delta T. Now, stylistically, people tend to put delta T last. This is like a style thing. It's a way of writing things. They always put the time last. So I'm going to go with that sort of traditional style as I isolate my variable. And then I say, okay, well, I want to get V1 over to the other side. So, of course, we know that we're going to subtract V1 from both sides. And I could rewrite this thing tidily again. Oh, did I do that wrong? I want to add V1 to both sides, don't I? Add V1 to both sides. And at this point, I've got V1 plus A times delta T. Remember, just stylistically, I'm putting time last. Not that it's right or wrong. It's a style thing. And then I can start subbing in my values now because the variable I was looking for is finally isolated. So, this is not a very complicated formula, and I'm even showing all of my thoughts as I go along in color. You don't have to color code your thoughts. I'm just doing this for teaching purposes, right? Okay, so we sub in our values, 4.0 meters per second plus 3.5 meters per second squared. And yes, you have to show your units the whole way through, just like you have to show punctuation in a languages class, times 4.0 seconds. And the reason that I got to show my variables all the way through is that in this case it might be fairly straightforward, but generally speaking, we should be able to look at the units. Hey, I've got seconds in the numerator. I've got a second squared in the denominator. That's going to cancel out one of the seconds, and that confirms for me that my algebra was good, because I've got units of meters per second here, plus meters per second here, and I can only add things together if they have like units. So that is like confirmation that I've done it well. And while this one might be a fairly straightforward algebra process, we want to make sure we get into that practice for all of our math, okay? We want to make sure that all of our units are present throughout. So 4 plus 3.5 times 4, somebody with a calculator, what does that end up being? Should be, starts with an E, 18.0. Look, 4 times 3.5 should be 14, plus 4 is 18.
In my defense, I didn't do the 4 plus 0 yet. I did that next step.
Okay. 18.0 meters per second. And then somebody's going to say, well, wait a minute, shouldn't it really be 2 sig figs? So here's the thing, and this is where we're going to have some interaction with the chemistry folks. Really and truly, look, if I've got 4.0 and 4 times 3.5 is 14.0, but look, I had to multiply these guys to get that 14.0, and they only had 2 significant figures. Shouldn't that have really rounded to 14? And then 14 plus 4 is 18. And so really, this guy didn't have any decimal places attached to it because of the rounding due to multiplying. And so this guy really should round off to approximately 18 meters per second. And that seems like a complicated thought process. What I'm generally going to say is that when we have a mixture of addition and multiplication, we're going to go with the multiplication rule of rounding to the lowest number of significant digits in the givens, which in this case was 2. That's going to be our general house rule for this course, okay? If there's a mixture of types of calculations, we'll round using the multiplication division rule. And I know that we could probably make things more complicated by chunking things and looking at it this way. We're not going to do the chunking method and looking at it this way. We're going to just round based on the multiplication division rules whenever we have a mixed problem. And most people are okay with that. That's going to be our in-class rule for this course, okay? And if you get into a really deep calculation methods course, then maybe it'll go more challenging than that. All right, so this guy is positive, so we're going to declare that The final velocity was west. And as I look at my sketch, I say, oh yeah, the horse sped up. That's what I predicted. The acceleration was in the same direction as the initial velocity. The horse sped up. That fits with my little sketch prediction. And the sketch helped me to think out whether this was going to make sense in the end. And of course, at the end, we should have a therefore statement. So therefore, the horse got up to a velocity of 18 meters per second west. And so I want to just zoom in on this and make sure we've got it. Things that you're going to have to make sure you include in every contextual word problem solution. You got to think about significant digits. You got to have units shown throughout. Make sure that you have formulas. Make sure that you have an appropriate reference frame, if a reference frame is necessary. And you got to have a therefore statement. And that therefore statement has to tie everything together. Basically make sure that the numerical answer or whatever makes sense in the context of the story, okay? And we want to convert all that math stuff back into English so that people can understand what the heck we just figured out, okay?
Will you get mad at me for not rounding away to point zero?
Will I get mad at you for not rounding it away?
Yeah.
No, I'll just mark it wrong. But I'll still be happy and like you. That's cool.
That's